topic in our sessions, and he's going to talk to us about new therapies in COPD.
I've been working with the PEP pioneers for over 20 years, well over 20 years. You guys have helped us with our research projects going back to the very beginning when we were just trying to prove that rehabilitation helped anybody, and we needed objective sort of findings, and a lot of you guys came over to our lab at Harvard UCLA and helped us with those studies. And it continues, and I see people all over here who have been over to the lab and helped us. My talk is a little bit different than it's been in the past. In the past, I've sort of had a focus on oxygen therapy or new things in rehabilitation. This one's more general for COPD and more general for what's sort of new and what stuff is coming along in COPD. And a lot of it is about clinical trials that are going on, and I'll be honest about it. I'm going to ask for those of you who can to come and work with us. Normal will be circulating among you for addresses and stuff like that. The thing you need to know is that we're interested in talking with you about participating in studies, but you never have to do anything, and we'll tell you about stuff, and if you don't like it, you don't have to do it. Even if you say you'll do it, you don't actually have to do it. But a lot of you know that we're reasonably nice people, and we're in there for science and for COPD. Here's a picture of the group. Not a great focus there, but it'll get better. Hopefully, aren't I a lucky guy to be surrounded by all these nice-looking people? That's not Peggy. Sort of isn't looking like my wife. She's not my wife. I have a very, very nice wife, Mary, who some of you will know as well. Over the Rehabilitation Clinical Trial Center, a facility that we established about 10, 12 years ago, strictly to do research in COPD. We've actually been doing pretty well. Thanks for taking part in COPD research. That's all we do. The story sort of starts here about COPD and research. COPD is a very high-impact condition. A lot of people have it, and we really need to find out more about it, but yet this slide shows that we're not doing very well in terms of spending money on it. The green bars are how much we spend annually in NIH money, your tax dollars, okay, to spend for research. And here's the bar for COPD down here. You can barely see it, but here's AIDS research. It's sort of off in the ceiling. Breast cancer, Parkinson's disease. Not that these things don't deserve a lot of focus and a lot of research money, but really COPD needs to do better. And we actually are. Since this slide was made, things are getting better, and we are getting some big studies that we need to answer the big questions in COPD. The facility that I had was founded 11 years ago now. We've got a nice big building on the LA Biomed campus, which is about 3 or 4 miles from here, over near Normandy and Carson Street. Our mission, the only thing we do is perform clinical trials aimed at improving the lives of people with COPD. We have a lot of people there. We got about a dozen people who hang around and scream and yell and have a good time mostly, especially when I'm not around. We just do a whole bunch of stuff. Some of you were kind enough to notice and comment, because I guess you get the Daily Breeze, that as of a story that was in there on April 9th, just a few days ago, was that LA Biomed wins a $10 million funds for a new research building. And that new research building is for, we're going to be in that new research building. The story is that about last summer, it was announced that there were stimulus funds from Obama, big stimulus money to stimulate the economy, trying to stimulate the construction industry. And to do that, they decided that one thing would be good to have constructed was new research buildings. And they had a big competition, and everybody applied. And we were lucky enough to win. And we won partially because we had 3 different groups, including our own, that does good research that's well-funded and are productive, but also that the facilities we're in are so god-awful that they felt sorry for us. So the quote that was attributed to me in this article was that our current facilities are ugly as sin. And sin is pretty ugly, actually. So we're really happy about this. We'll be about 2 years before the building's built, and then we're into it, but we're really very happy that our efforts have been recognized and that we're going to continue. So what I'm going to do today is talk about some things having to do with COPD therapies, some new information on current therapies that a lot of you probably will find familiar, some new drugs that are coming down the pipeline and whether we're actually going to get them or not going to get them, and then work in progress, mainly focusing on stuff that we're doing, stuff that we're just finishing up, tell you about what we're finding, studies that are in progress, studies that are starting soon. The stuff about current drugs, everybody recognizes the names, probably will recognize the names Spiriva, Advair, and Symbicort. They're the sort of our go-to therapies for COPD, for maintenance therapies, things we take every day that seem to do well. And the FDA says, yeah, they're good. These are really two different kinds of drugs. This one is called an anticholinergic, one way of making the airways larger. These two are fairly similar drugs. I have no interest in saying one's better than the other, but they're a combination of an inhaled steroid and a beta agonist kind of bronchodilator. And what we know about them is that what we read in the New England Journal of Medicine. New England Journal of Medicine is the most famous medical journal, and we're supposed to think that anything it says is probably right. But these are two trials that appeared in New England Journal, one having to do with tiotropium spiriva, and the other one having to do with Advair, that was published in 2007, 2008. See, in order to really learn a lot about therapies, you have to do big trials. And these were a case in point. Kathleen Nourielak just came in late, but well appreciated. Also from my lab. So you need big trials to find things out, and these were big trials. It's focused on finding out what the long-term benefits of taking these drugs were. And what we learned was that these drugs work, and the trials showed that they were safe. It took 6,000 people in each trial. These trials were either 3 years or 4 years long. So realize the expense and difficulty of doing these trials. But this showed that Spiriva and Advair had additivity effects on airflow, that they were both good, and this one added to this one, and they both decreased the amount of COPD illnesses. You get sick less often. You're on these drugs, which is a good thing to do. And that if you're treated earlier, it seems to help. So these are good findings that show us the drugs we're taking now are essentially, by these trials, safe and are pretty effective. Now, they're not perfect, and they don't do everything we'd like them to do, but at least what we have is it seems to work pretty well. What do we have to offer coming soon? Well, we have some things, and this is like a glass is half empty and a glass is half full. It's half full because there's some stuff coming, and it's half empty because there's not enough. But here's what we have coming soon. Here's one, a drug called Indicaterol, sort of a mouthful. It'll get a trade name, hasn't gotten it yet. But it's a once daily beta agonist. We said, well, I thought we had a beta agonist. Part of Advair and Symbicort have a beta agonist, but it's a twice a day beta agonist. Indicaterol is a once a day beta agonist. In other words, take it once in the morning, then forget about it. It's actually been approved in Europe. Europe is usually a little faster than we are. That's sort of good and sort of bad. The FDA is very conservative. If they let it go, you're pretty sure that it's going to be very safe. But then again, you have to wait for it longer. So the Europeans have said it's okay. The recent hang-up in the FDA, they went to the FDA and they said, well, yeah, it looks pretty good, but why don't you do a couple more studies? So, okay, they're busy doing some more studies. The company that makes this is Novartis, a big pharmacia company. And again, maybe in a year or two we'll have Indicaterol. And actually the focus here is to eventually get to the point where, just like you take Spiriva once in the morning, well, you take one inhalation and you'll get a Spiriva-like drug, and you'll get a beta agonist-like drug, and maybe even an inhaled steroid, and then you can go the rest of the day until the next morning without taking one again. Now, that will be nice. It'll be more convenient. But what we really need are drugs that work differently and work additively in COPD. Here's another one, Roflumilast. Its name is going to be Daxis. It's another mouthful sort of drug. It's a drug you take by mouth. We haven't had drugs we take by mouth for COPD for a while. The good part of it is it works as an anti-inflammatory and a little bit of a bronchodilator, but it upsets some people's stomachs. In fact, they found that people tend to lose weight while taking the drug. Now, is that good or bad? Good. Well, it's good, except if they said you're going to lose some weight, but you're going to be nauseous part of the time. Nah, I don't want that. So I don't know. The point is that it reduces COPD illnesses. Currently, the FDA is looking at. In fact, just last week they came out and they said, nah, not yet. So they're sort of going back to the drawing board with this drug. Nycomed, a company that we don't hear about very often, makes it. Interesting new mechanism of action, probably will be additive to what we have, so that's good. But again, not quite ready for prime time. These things go slowly. Tell you about some studies that are finishing soon. These are mainly stuff that we're doing in our lab. Some of you guys have been kind enough to help us to get to this point. A lot of the focus we have is on this fancy word of exacerbations. In other words, getting sick. People get sick from COPD, and you all know it. You get a lung infection, or you get a bronchitis, and sometimes you can cut it off, and you can get better, but sometimes you can't. You go to the hospital, it's very expensive, it's miserable, it costs a lot of money, it's all kinds of stuff. And if we can just find ways of decreasing the frequency of exacerbations, we'd actually do a good thing. And we've actually been getting better at that. I think I've got a slide here that sort of shows that. How do you decrease the number of times you get sick? Well, we got a list of them. Taking flu shots, no-brainer. Everybody should have a flu shot, especially if they have COPD. Pneumovax shots, pretty much a no-brainer as well. You should have every 5 years, you should have a pneumovax shot. Turns out that long-acting bronchodilators, drugs like Spiriva and Ceravent decrease exacerbations. Inhaled steroids, do it. Pulmonary rehabilitation does it, huh? Yeah, you bet. Self-management programs, you're working with your doctor closely, so you sort of teaches how to recognize a problem, get to see him early, that works. People who need oxygen, supplemental oxygen does. So we have a whole bunch of ways of doing this. Do we have enough? Well, we never have quite enough. And here's the next possibility. What about, we know that antibiotics are good when we get sick. How about antibiotics for preventing getting sick? And that's an interesting idea. And you say, well, geez, I thought we have resistant bugs going around if we take antibiotics all the time. Well, that's true. So we have to make sure value the risks and benefits. So we designed a study called the macro trial. Macrolides are one kind of antibiotic. And said, well, people are going to come in this, and for 1 year they'll take one pill in the morning. It's either going to be a macrolide antibiotic. It's actually zithromycin, Zithromax, like Z-Pax, common antibiotic. Take it every day, and versus half the group's going to get that, and half the group's going to get placebo. And at the end of the year, we're going to see who gets sick more often. Okay? And we did this. This trial was your tax dollars, NIH trial, by a network that we belong to. Recruited 1,130 people. Got to do a lot of people to do this. And we got 99 people were recruited. Right, Kathleen? We couldn't get to 100. I kept on bugging her. Couldn't get to 100. 99 people. And we're measuring whether people get sick, how often people get sick. And the answer is, well, we started in May of 2006, and we recruited 99 subjects. We'll complete this study in June of 2010. The last person will leave the study. We're finished recruiting people. And then you get like a Christmas package. You open the box and find out what the answers are. You can't peek beforehand. You gotta wait till the end of the study. So we'll know. And this doesn't mean that everybody's going to be on antibiotics, even if the study's positive. But it will mean that perhaps people who just keep on getting sick, well, maybe this will be a good option. We'll be able to tell doctors that this is a reasonable way of treating people. But realize you can't find this stuff out unless you do these big studies, because you can't. This is not a thought experiment. Does it work? You just have to see. And again, we needed 1,130 people taking the drug for a year or not to find out what the answer was. Another study finishing soon. Can we regrow lungs? That sounds like a good idea. Why not? We grow fingernails. Grow hair a little bit, Why can't we regrow lungs? And the answer actually is that it's absolutely clear that we can. We just don't know how, right? We found that rats can do it. People can sort of take apart their lungs if they starve. They can probably regrow if they get better. So we just had to find the switch. And our first try was a drug called, well, it's a retinoic acid analog. It's sort of a vitamin A relative. And in rats, it regrows alveolar tissue. So we decided to do, studies in man have been inclusive. So they found this related molecule that has better characteristics than the original stuff, RAR gamma. And it's been tested in some short-term studies. So again, a large study, 480 people with emphysema, because with problems with lung tissue, at 40 different sites. We participated. We recruited about 15 people. Got either RAR or placebo for 2 years, okay, on optimized treatment. And then we use CT scans. CT scans are really wonderful these days because it can show you what the lungs look like precisely, and whether the airways are big or not, and whether the lung tissue is there or not. And we can actually tell whether the lung tissue is regrowing. So we did some CT scans on these people to see what was going on. And again, this one is just finishing up. The last person is just about to leave it. And again, we're waiting to see what the answer is. Did we regrow some lungs? Did we not? Did we get a lot of side effects? Did we not? Placebo-controlled, double-blinded. Double-blinded means that neither the person who's getting it nor the people who are giving it can know what the patient's getting. There's some codes and things like that. So we don't know what's going to happen. But this is a really good study. And again, some of you may have participated in this stuff. A very good study. It may turn out to have very interesting results. Another one, stem cells. Everybody's heard about stem cells. Well, we did a stem cell study. The first one done in COPD. I actually fought very hard to get our center enrolled in this because I wanted to do it because I was interested. I thought it was a good idea. If you introduce stem cells into the blood, a lot of them go to the lungs, and we think they may initiate repair things. Maybe like repairmen going up there and sort of clunking around and seeing the thing replace lung tissue. That was the theory, at least. Decrease inflammation. And this study, we obtained stem cells from healthy volunteers and grew them up in a laboratory. I shouldn't say we, because it wasn't us. It was some very clever cell biologists who did this. And they shipped us these bags full of stem cells frozen. And we thawed it out and, under very careful conditions, gave them to people with COPD. 60 people around the country. We did about, I can't remember, 8 or 10? Maybe 11 or 12, yeah. We did our share. And this started about 18 months ago. I'm sorry, 12 at our site, it says it there. And, well, what I can tell you is that nobody got up and danced, okay? I can tell you, on the other hand, nobody seemed to have any bad reactions to it. That was very important. This was one of these studies where the benefit was high, but the risk was high because we'd never really done this before. Well, it turned out nobody was harmed by it to any extent that we can tell, but nothing's clear about whether the results are positive or not. And again, we're waiting for the end of the study to find out what happened. How about things that are in progress? We're doing a couple of studies now that are really interesting, and some of these we'd love to have your help with. Please consider joining us in these studies. This is my favorite one from a lot of points of view, called COPD gene. This is one that Norma spends all her time doing. The idea is, okay, here's the question. If you have 100 people and they're all 65 years old and they've all smoked, they're smoking now, smoked before, they smoke pretty heavily, 100 people, what fraction of those people are going to have COPD?
25%.
What's that?
25%.
25%. Well, you peaked. That's about right. About 25%. And to some people that comes as a surprise because tobacco smoke is pretty nasty stuff. Why doesn't everybody get COPD who smokes? Well, it must be that some people who smoke have defenses against evil tobacco smoke, and they somehow are able to throw off those bad influences. Well, what would they have? Well, it must be something in their genes that means that people won't get COPD. So about 25% each peaked. So what protects the 75% of smokers from getting COPD? And the answer is it's got to be genetic. but we don't know what it is. We think it's genetic. I mean, I know that because in my family, all my grandparents' generation who smoked all got COPD. The ones who didn't smoke didn't get it. I didn't get it. But I know it runs in my family, so it must be genetic. So what we're going to do is determine what is really the root cause of COPD. And then hopefully be able to use the information to design new therapy. So imagine this. You get, you sort of recruit a whole bunch of people, all of whom smoked and would have gotten COPD if they were prone to, and some of them will not have COPD and some will have COPD. So what we then do is to examine their genes and find differences. We find that it's common in this group, not common in this group. Well, what does that gene do? We're hoping to find 6 or 8 or 10 genes that seem to predispose for COPD. And then find out what those genes do. Maybe they'll tell us something that we didn't expect. Maybe some enzyme in the body that is missing in the COPD patients. Maybe then we can give it to them and help them out. That would be the great result of a study like this. But again, doing the study is a lot easier than stating the premise. So here's a study. Again, NIH funded. Your tax dollar is about $25 million grant to do this. Collecting 10,500 people. That's the hooker. 10,500 people, because that's what they calculated to get the answers. You'd need that many people. About half of them, all of them with smoking histories, half who have COPD, half of them who don't have COPD. What we do is we bring them in, they take a blood sample, because in your blood is white cells, and white cells have your genetic material. So once we have your white cells, we have all the genetic material we need. We do lung function tests, spirometry, blowing to a thing, some questionnaires, and then a CT scan. Why a CT scan? Because again, as I said, CT scan tells us what kind of COPD you have. Got big computerized processing to determine to quantitate what's going on with a CT scan. It takes about 5 hours, maybe less. 2.5. Norma's getting very fast. 2.5 hours in the lab to participate. And then we send your blood goes off to get educated. We send actually these samples off to Harvard, to a lab at Harvard, and they do what's called a whole genome analysis, which is one of these amazing high-tech things. They essentially analyze 1 million different characteristics of your genes. I mean, it's just staggering that they can do this. A little microchip. I don't know. I don't understand how it's done, but it's a million genes, characterize them, and again, then compare the group of people who are smokers with COPD to those who don't have COPD. The nice thing about the study, well, I recruited Norma and her co-worker Carmen about 2 years ago to recruit people for this study, and I said, you got to recruit at least one person a day, and they really didn't understand, so that was impossible. So they did it. So that was absolutely marvelous. We are supposed to recruit 800 people. We've got just about 500 people to date. 500 people have come and participated in the study. It's been an absolutely wonderful study. There's been 7,799 as of last night nationally, because there's about 20 sites around the country doing this. So we are ahead of our schedule to recruit 10,000 people. This is again a very nice study. The people who would like to participate, we'd love to have you. The advantage of participating as well is one is you get 80 bucks. 80 bucks isn't going to do very much. But the CT scan is actually interesting. It's a cancer screen, and you get a reading that we send to your doctor. That's a very high quality reading for cancer screening. Look for nodules, lumps and bumps and stuff like that. A lot of your doctors will do that for you every once in a while anyway. This thing does it for without a charge, of course. So that's COPD gene. If you're interested in that, we got brochures and you can sign up. And again, for this one, you come over for a little while. Terry, you got a question?
Well, I actually want to give a testimonial.
A testimonial?
Yes, I participated in this, and it was 3 years. And, I was able to keep track of how my lungs were functioning. And then I got very sick, and then my lungs actually were functioning better. And then you did a CT scan, and they found that I had an aneurysm. So it was really good
Yeah.
information
Yeah.
for me. Every year I got great information, so it was
Well.
well worth the study.
Thanks so much. I paid her to say that. No. Terry's been kind enough to come around for many years. We really love seeing her. So that's a good study. That's actually an easy one. That's an easy one. The other two are, well, a little less easy, but I'll tell you about them anyway. This study is about oxygen, okay? I see there's a bunch of people with stuff in their nose. Well, why do we do that? Well, we do that because Tom Petty, our sainted Tom Petty, told us that people who get oxygen therapy, if their oxygen levels are low, live longer. I mean, not a little bit longer, a lot longer. That having low oxygen levels is very bad. And this is the study that was published in 1980 or 81 that sort of showed us that. And this is a very important and interesting finding, and as a result, we spend $3 billion a year in the United States on oxygen therapy. But it only applies to people whose oxygen levels are very low. Very low meaning your saturation is below about 88%. Well, the question then becomes, well, okay, that's good. We certainly want to give people whose oxygen levels are very low oxygen. But what about people whose oxygen levels are not quite as low? For instance, those people who have oxygen levels that are a little bit higher than that. Well, do they benefit? Well, we don't know because we never looked. We've never done the study to determine that. What about people whose oxygen levels are okay sitting around at rest, but if they get up and walk around, their oxygen levels fall? Well, we sort of tend to give oxygen in that circumstance, but we really have never checked to see if it does help. And some people do and some people don't. What we need is better evidence. So here's this next trial called the long-term oxygen therapy trial, a wonderfully constructed trial, but it's sort of a tough one. Again, it's a lot of work. And 14 sites around the United States competed. We fought to be part of this trial, and the bad news is we succeeded, right? Because it's a tough trial. So we succeeded. There's 14 sites that were selected, and we had a long design phase, and we began recruitment. Geez, just about a year ago. And here's the way the study works. We're going to study about 1,200 people, about 81 per site, including ours, with one of two things. Either their oxygen levels will be sort of moderately low, not meeting current criteria for giving oxygen, okay? And we'll take those people, if they agree to participate, we'll either give them oxygen or won't give them oxygen, okay? Because we don't know if it's going to help, so we'll randomize them to receive full-time oxygen or no oxygen at all. Or the second part of the group will be people whose oxygen levels are normal at rest, but who drop during exercise, and we'll randomize them to receive either no oxygen or just oxygen when they exert themselves. Makes sense. And then we'll follow them for a couple of years to see what happens, see which group does better. And we don't know. Help us with this important study. We need people who are recruitable. People who are on oxygen currently aren't going to qualify. But those who aren't, we would love to have you participate. I think that the oxygen supplies are free of charge. There's no copay with the oxygen, for instance. Compensate for electricity costs because the stationary units usually cost money to run. $100 a year is not much for your trouble, but it's a good study. We would love to have a couple of people who would come along with us, and see if you qualify and then participate. This is one that if you're all interested, we'd love to talk to you about it. Well, this last one, a study starting soon, that was last week's slide. It's actually starting now. This is a third study. Who's on statins? Lipitor, all those things. Bunch of people. Okay, why aren't the rest of you on statins? Because your doctor said you didn't need them, right? Well, that's because your cholesterol was probably okay. We know that statins are good for people, are cardioprotective for people who are on, whose cholesterol profile is not very good. And it's a miracle drug for that purpose. It really is. It's a drug that side effects are usually pretty good, and we know that it reduces dying from heart attacks by a substantial amount in people whose cholesterols are abnormal. But it turns out that it may be good for other things as well. do people with normal cholesterol levels benefit? And the answer is, we don't know. We don't know. We're going to find out. COPD patients, it turns out, not only have a high incidence of lung problems, they have heart problems as well. And the thought is that statins may benefit COPD patients even if their cholesterol levels are normal, but we don't know. So that's the question we're asking. So again, an NIH project, a fair amount of money being pumped on this. We're going to recruit 113 people at each of 10 sites, in other words, another 1,130 patient study, big study, who have a history of having COPD illnesses, exacerbations. Now, why is that important? Well, because we have a suspicion that these drugs may help the lungs as well as help the heart. Anti-inflammatory, inflammation, that's part of COPD. And inflammation is what statins tend to reduce. So we think that it's possible that statins may help inflammation in the lungs and may in fact make people get sick less often from the lung disease. So, history of COPD illnesses, not on a statin drug currently, because we're not going to drag it out of your hands if your doctor already has you on it. And in fact, what we're going to do is when we bring people in for this, is we're going to check your cholesterol profile to make sure that you don't have an indication for it anyway. So if your cholesterol is abnormal, we'll send you back to your doctor and say, hey, you probably should be on it. Not in this study. And so what we'll do is then take people and randomize them to either get a placebo pill or a statin, once a day pill, and then follow them for between 1 and 3 years to see how they do. Looking for things like frequency of COPD illnesses and frequency of heart problems. Makes sense, yeah? And again, until we do it, we can't find out. Study started last week. We randomized our first subject. We got 3 or 4 people in. Kathleen's
7.
We get 7 people in. Well, I'll count my chickens when they hatch.
One random.
Not your chickens.
7 in.
Is there an age limit on that one too?
Oh no.
Yes.
Yes. Jeez.
That's 80.
Okay, we went through
We'll
that
take you
before.
right up to the day before your 81st birthday.
81st birthday, is that right?
We'll take you right up to the day
Right up to your
before.
81st birthday.
Now,
You leave me out every time, Rich.
Oh well, it's not my fault.
age discrimination.
The study pays $300 a year, which is again it's a small compensation, and of course there's a whole bunch of lab tests we'll do, which we will share with you and your doctor. So that will sound pretty good. We got a lot of stuff going on. So anybody who wants to come over and yell and scream with us and be poked and prodded, we very much would appreciate it. So I want you, the dual purpose is one to sort of tell you what we're doing and entice you to come over, but just show you that there really is stuff going on in COPD. We're really trying hard to find new therapies. It may seem like we're moving very slowly, and God knows I feel that way too, but we are trying, and we'll succeed. We'll succeed eventually. I'd be glad for any questions you might have. Carlin.
A couple of weeks ago on 60 Minutes, they had a show on genes being patented by pharmaceutical companies. I think it was breast cancer, BRCA, or
Yeah, but breast cancer gene. Yeah.
Is that going to be a problem? I mean, as researchers, I don't see it as a problem there, but the pharmaceutical companies getting involved in this.
Yeah, I can tell you that the COPD gene study is not going to suffer from that problem because it's a federally funded project. Anything they find is public domain. It wouldn't be a concern. Is that a possible result from some of the others? I don't know. There are some genetic studies in some of the pharmaceutical trials, and I don't know. I don't know anything specific, and I think the practice is terrible. It's ridiculous that people patent somebody's genetic material. It's crazy.
Did one thing to patent a cure, but
Yeah, that's correct. A treatment is patentable, but not a genetic, essentially an organism, a biological entity. But I think that they're working on trying to. 60 Minutes is a very powerful organization. I think they're going to try to
it usually
overturn
works
that.
me up.
Yeah, I agree. I saw the same show. I thought it was terrible. Hi.
But go further on that. It's publicly funded, but we know that the government
has patents on lots of drugs, and they license them to pharmaceutical companies. So what's to keep the feds from patenting this gene and licensing it to Genentech? It's done all the time. The feds are licensing on AIDS drugs.
You know, I may not have a full understanding of this. Maybe I'm not sophisticated enough. My understanding was that it's not the feds that own it. Sometimes the universities own it. They can license it out. I sign a whole bunch of things that say that nothing I do belongs to me, and I don't think the feds. I shouldn't speak. I guess I don't know. That you know, we bash pharmaceutical companies, and I must say, let's full disclosure. I work for a whole bunch of pharmaceutical companies. I consult with anybody who will listen to me. I consult with because they're the ones who have money for the trials. You take a look at these trials. Nobody, you know, the government trials. We spend $25 million, and we say, wow, that's great. To bring a drug to market, it takes more than $1 billion. It's just crazy, and a lot of times it comes right to the market, and then they don't go across. So there's got to be a happy medium that we probably aren't at yet. The pharmaceutical companies should have some credit for what they do, but yet have some restrictions.
Well, her question, and I see where she's going, and I'm concerned about it too.
Yeah.
You know, I participated in a study, and you find out that my gene is immune to whatever. I don't want Genentech running out.
And patenting that gene.
Oh, hell no.
Yeah, well, I understand that, but this is not the approach that's happening here. I know the groups that are involved, and that they've had genetic discoveries, and this is not what happens. I'd hate for people not to participate in the study for that reason. The genetic material, incidentally, is all anonymous. It has nothing. There's nothing that usable that would give it back to you anyway. But it's absolutely anonymized. Nobody knows who's
So nobody's asking us to sign away any.
No, in fact, your name never leaves the Harbor UCLA campus.
We're worried about our names.
Yeah.
We're worried about our genetic material.
Well, the genetic material that we're looking for is something that's common in COPD patients and not common in the other group that distinguishes the groups. So it wouldn't be your specific gene that would be the exciting thing. It would be something that's present in a whole bunch of people.
Okay.
I think that I'm not sure if that's
You
revealing.
answered the question.
Yeah. Okay. That's what we're looking for.
You hit it right on the head.
Okay. Well, thank you. Please.
If you use oxygen, do you get accustomed to it to where you're dependent on it?
You know, my mother used to do that. My mother had emphysema, and she said, "I don't want to take the drugs. I don't want to take because then when I need them, they won't be there." She would say that to me, and the answer is no. That's not true.
You don't get the
You don't get used to them, and then they don't have effect. There are one of the very important characteristics of drugs that are on the market is they don't have a thing called tachyphylaxis. It's a fancy word for saying the effect doesn't go away after a while. And oxygen is exactly the same. Use oxygen, it's good for you. It's as good for you today as it is a year from now or 2 years from now. And the effect doesn't wear off, and you don't get used to it. If you need it, you need it, though, right?
Thank you. I do have another question. This study with the monster antibiotic, whatever.
Zithromax, yeah.
Right.
Not monster.
My physician wrote me a prescription for it years ago.
Mm-hmm.
And maybe the price has come down. Actually, it wasn't my physician. It was a physician who's a friend of my mother. And again, this was years ago. I go trotting off to the pharmacy, and it was $150 for the prescription. Is the price still about the same?
Interestingly enough, the reason why we chose Zithromax is because it was going off patent. And in
okay.
fact, it's generic now, and it's a good deal cheaper.
Okay, so
It's a
you
good deal
answered
cheaper.
my question.
Yeah, right.
Okay, that was part one
Right,
of my
yeah,
question.
no, that's fine.
The other part B, is it's a monster drug, meaning that it is extremely effective. That antibiotic kicked, I had bronchitis, by the way.
Yep.
This was leading up to my COPD. We didn't know it at the time. It kicked that bronchitis. I was up and out of bed in 2 days, where I wasn't able to lay down and breathe.
Yeah.
It kicked it out in no time, so it's extremely effective. That leads me to ask, if we start taking a monster antibiotic, oh, he knows where I'm going. This man is too smart.
Please finish the question.
No, go ahead, answer my question
Well,
before I ask. Don't take those Bruins.
I apologize. I didn't interrupt you.
Bruin. Go ahead, tell him. Go ahead,
I'm a
speak.
Trojan who's Bruin friendly.
No, you're 100% right. Everything is risks and benefits. Everything's risks and benefits. And we are very carefully assessing whether we get resistant bugs. Anybody who did the study knows we stick a swab in your nose every couple of months and culture it to see if we're getting resistant bugs. Now, if it turns out that the thing helps a little bit, is a little bit of benefit, but we get resistant bugs, we'll say this is not worthwhile.
Yeah.
And on the other hand, if it's very effective and we don't get many resistant bugs, we'll say, yeah, for some people this would be good. But you can't tell unless you do it. And a lot of you talk to an infectious disease doctor, they'll say, geez, I wish you wouldn't use antibiotics for this purpose. But if you talk to a pulmonary doctor who's trying to keep the patient out of the hospital because they keep on getting sick, they'd say, geez, I'd like to have this tool if it works. So your concept is perfectly good, but we work that through. That's excellent.
Thank you.
Thank you. Other thoughts? Please.
What are the effects of taking Advil for years? Eyes?
Pretty well. That's a good question. Let me start off by saying that the fact that we take most of the COPD drugs by the inhaled route is a good thing, because they're designed to not go across mucous membranes. They're designed not to be absorbed. So they generally stay in the lungs and they don't get systemically. If you took the component of Advair, the steroid, orally, that has a lot of bad effects long term. The fact that it's inhaled means it doesn't circulate in the blood very much at all. And therefore the side effects profiles are good for these inhaled drugs. They're not perfect. There's a concern, for instance, that taking the inhaled steroid for many years may thin out your bones a little bit. And there's some experimental evidence that by tiny amounts, maybe. But the benefits are substantial, so you say, well, that's okay. And there's some worry about glaucoma because steroids do that, but it's low dose and it's in the lungs. We think that's okay. So the risk benefit is actually pretty reasonably good. There's actually been a worry about taking the beta agonist component in asthma. It's a big deal in the newspapers, but it doesn't apply to COPD. So we're always looking to make sure that our therapies are safe. But frankly, the ones we have now, they're reasonably effective and they're pretty darn safe. And it would be a shame to get any of them out. So Advair is a good drug. And I think
Why do they say only use it for 6 months? I've been using it for years.
I don't know who said taking it only for 6 months.
Small print on the package.
Well, what does it say? What does it say? I don't remember. I don't think for 6 months.
Something along
Something about reevaluating. I think they want your doctor to reevaluate you to make sure it's working well. But many, again, do what your doctor says.
I'm on it for that many years.
Well, it's hard to tell sometimes whether you're being helped because you don't know what you'd feel like without it.
Well, yeah, I'm afraid.
You don't know. So, do what your doctor says is a real answer.
Are all of these tests that you're talking about for patients under 80?
Well, you answer me. Is a lot under 80? Lots not. Lots any age.
Right.
We have other studies too that come around. We'll find something to do. I'm embarrassed because I don't believe that these age cutoffs make any sense anymore. Because people are you're as young as you feel, I think the lot study, if you're interested in that, would be eligible for it. Teenager. You don't lie about your age, what the hell?
There's some teenagers in the
Yeah. Well, some studies will ask you if you have cancer, and the thing is, we're looking to study the effects of these drugs in this illness, and if you have other major illnesses that are going to make it hard for us to determine the effect of the drugs, it may make you not qualified. So we'd have to do it on a case-by-case basis. Thank you for that. Sir.
I have a question about giving statin drugs to people with normal cholesterol. Are you going to supplement coenzyme Q10 as well?
No. Tell me, why should we?
Do not statin drugs act on the liver, and the liver produces cholesterol as well as coenzyme Q10. I was at, I think it was called it was an aging seminar given by FIFA. And the doctors brought that out, that if you're taking the statin drugs, you should supplement coenzyme Q10. And another thing that would concern me is, if you have normal cholesterol and you take a statin drug, now you're going to have less than normal cholesterol. Isn't that going to have possibly a long-term effect on your health?
You know, you the first question exhausts what I know. I don't know whether coenzyme I know what it is, but I'm not aware that people with statins are regularly supplemented for it. Well, wait a minute, I do know. I take statins, and I'm not supplemented. And my cholesterol, incidentally, is 120. And I think that's great. This came down like a rock on a very low dose of Lipitor. I think we have enough experience with statins in people who are taking for cholesterol purposes to know that there are certainly side effects of statins, but they're usually pretty manageable. And we monitor people. For instance, we monitor people for liver function problems and for muscle enzymes and stuff like that. Probably much more compulsively than your doctor might typically, because we're doing it for research purposes. We want to make sure we don't hurt anybody. I don't think that low cholesterol is a problem. I don't think that's a disease. I think that's generally a good thing.
Well, I'm not going to argue with that.
Well, you might know more than I do. We've never come across that in terms of it's not part of the risks.
That liver's in there doing that.
Well, it's certainly
part of the plan.
It's certainly is. What you're saying, it's not nice to screw with Mother Nature. Yeah, I hear you talking, but we do that all the time. We fool with Mother Nature a lot. Well, I think I'll stop there. You guys are always wonderful to talk to. I'd be glad to talk to anybody else who wants to come up and talk with me. Thanks so much. And if you guys come over and see us, we'd love to have you. We'll send out sign-up sheets. If anybody puts their phone number down, we'll call you once. If you want to talk to us again, we'll leave you alone. Promise.